Now we're going to look at a couple of applications for these angle measurements. First, talking about arc length, where it's a natural thing to do here because we get the idea of an angle in terms of radians from length over the radius. So if we want to get length of an arc and we have an angle, S is just equal to the radius times the angle measure. S equals r theta. And for this, we're going to look at an example. So suppose we have a circle with radius 7 centimeters. And what we want to find is the length of the arc created by a 135-degree angle. Well, first thing you have to bear in mind is this S equals r theta relationship only really works if we're talking in terms of radians. So the first thing you're going to do is take that 135 degrees and multiply it by 1 like we just did in that last example. So we've got 135, we want to get rid of degrees, so we're going to divide by 180 and multiply by pi radians so that we're left with that radial value. And that, degrees cancel with degrees, 135 over 180 is 3/4. We've got a pi, so we have 3 pi over 4 radians. And from there, we just multiply out, where a nice thing about the way that these units are set up is those radians are going to get caught by being multiplied by a radius, and we'll just get that S is equal to 7 centimeters multiplied by 3 pi over 4 radians, which just ends up being 21 pi over 4 centimeters. Or if you prefer an approximation, about 16.5 centimeters for the arc length of the path followed along that circle. And the last thing we're going to see in this section is a bit about how fast something can make that traversal. We're going to look at what are called linear and angular speed to get a sense of how quickly something can move along a circular path.